Hello again, I'm John Ball. To get working AI, including robotics and human language, we need a solution to the frame problem of AI. But what is the frame problem? It's the design needed to operate a complex machine in real time. When a robot walks across a crowded room like people do, how does it avoid walking into people and causing injuries and death? When interacting with language, how does it understand the inferences that people recognize? We can say it's just common sense, whatever that is, but one aspect of the frame problem in language is seen with events. Take a meal in a restaurant, for example. You walk into a restaurant, stay for a while, and leave a big tip with your payment. Now, did you eat? Why? Well, I think yes, we ate because the tip is for good service and a restaurant is a place to eat. Philosophically, this is also constrained with Grice's maxims that I won't be getting into today. Our brains are excellent at contrasting events. Consider this variant. You walk into a bar, stay for a while, and leave a big tip with your payment. Sound familiar? Now, did you eat? No, because bars are for drinking. What about you walk into a friend's garage, stay for a while, and leave a big tip with your payment? Well, this makes no sense at all because we don't pay our friends to spend time in their garage. The point is that these kinds of inferences require a model that is learned from experience of the world, not from word sequences in books, for example. We rarely write the details of these events because they're lengthy and can be assumed to be known to readers or speakers. Now, next time, I'll explain why the AI frame problem aligns with a brain model like my pattern brain theory. Brains can teach us a lot because they're really good at things that computers aren't. They already do AI. We recognize an astronomical number of subtle variations throughout our experiences. We recognize a human tennis server despite many variations in stance and handedness. Left-handed tennis players are as easily recognized as right-handed tennis players. We recognize languages despite a range of accents. We recognize written words despite variations in fonts. We recognize events like parties despite how people are dressed and what the decor is and what the music is. We choose a response to a blur of an animal on a roadway in front of us at night in a fraction of a second, considering a vast number of features and risks to passengers and pedestrians. The frame problem is central to solving AI and emulating humans. Remember, brains are much slower than computers, but brains are much faster at solving many problems. Therefore, solutions require better knowledge representations, less processing to do, and the ability to learn from experience in order to run in real time. We can see attempts at solving the frame problem with AI. The use of statistics, innovative search algorithms, reasoning techniques, even artificial neural networks. But just because we have a tool doesn't mean we're emulating the human brain. Lack of success also suggests we're not emulating the human brain, by the way. Today's article looks at where the frame problem came from, as well as its goal as an essential part of the path towards strong AI, or AGI, artificial general intelligence. My answer from solving this problem over years may surprise you. Please read on to learn more.